All right, this video is the second half of Module 16 notes about um, selective attention and thresholds. So first of all, this slide you'll find that I don't have a whole lot of actual words on here, so if there is stuff that you want to add into what I'm talking about, go right ahead. So here we're talking about selective attention. So selective attention is this idea that kind of like when in the last video we talked about dual processing and that your brain is picking up a lot of conscious and subconscious things. Well, what you choose to pay attention to is what we call your selective attention. You're selectively paying attention to it. So you can kind of think of it as your brain spotlighting on something, right? So you're spotlighting on a particular thing. So for example, maybe right now you're spotlighting on the sound of my voice, and so you are selectively paying attention to that. But because of that, you are also becoming blind to other things. So there's two types of blindness that this causes. So the first type is what we call inattentional blindness. So for example, inattentional blindness is going to be any time that you just don't notice something because it is outside of your selective attention. So it's still there. It was always there. You just didn't notice it because you weren't paying attention to it. For example, I always point this out is that did you realize that every single classroom in Chittard has a saint, a plaque of a saint outside of its classroom? So you walk by mine every day. Does anybody know what the saint is outside my classroom? San Juan Diego. That's the saint outside my classroom. But that's an inattentional blindness because it was always there outside my classroom. You just never really paid attention to it, so you didn't notice. Now you're going to go in tomorrow and you're going to look, right? Okay? Change blindness, on the other hand, is going to be when something changes in the environment and then you don't notice it because it changed, right? So a good example of this, practical example of this is that, when somebody goes and, gets a haircut, right? So, or they style their hair differently. Girls are more likely to pick up on it. And I'm not saying that the girls are better at change blindness than guys, but the hair thing, girls pick up on more often than guys. Another good example is if, you had somebody that either usually wears glasses and then they get contacts, or somebody who usually wears contacts and then they wear glasses, and you look at them and you're just like, something's different about you. I don't know what it is, but something's different, right? So I have a couple of videos for you to kind of illustrate both of them, and so we'll talk about them after each one. So this one, the first one I'm going to show you is actually a video from a prior student. It was one of the first things that I did was I used to do a project where I had all my psychology students do a research project where they conducted the research. But I don't really do this project anymore. But the research they conducted for this particular group was that they were doing this video, and they showed this video to several of their participants in their research study, and they basically conducted this study, and so I'll let them explain. So I will tell you that the student that's flipping the cards and the voice that you hear is Evan Berenger. He was a 2016 grad, so if you remember him, that's who it is. So I'll just let him speak for himself.
So count every red card you see. So that would be 1. Ready? Go.
Okay, very quick. How many red cards did you see? Did you notice anything else? Let's play it again. Pay attention this time and see if you can pick up on other things.
So count every red card you see. So that would be 1. Ready? Go.
All right. Did you see anything else? when you're watching this, you pay attention to this part of the hand, okay? Now, when you pick it up,
So
you
count
can
every
actually
red
go
card
and
you see.
watch, and you can
So that would be
see
one,
there's
three,
actually a message on the back of the cards. There's a clock, and it says, "Are you reading this right now?" And then they have an eye. Okay, so what is this an example of? Inattentional blindness or change blindness? Hopefully you said inattentional blindness, because the messages were always on the back of the cards. You just didn't pay attention to it the first time, or maybe the second time. Hopefully you picked it up the second time, because you were busy counting the red cards like he told you to. Okay. This is an example. This was not a student of mine. So this one is actually an interesting example, and it shows kind of a classic experiment.
You are about to take part in a quick experiment. Take a look at this. Okay, now, did you happen to notice anything odd? Watch again. See any changes? Don't worry if you didn't see that it's two different men. It means your brain is doing exactly what it should be. It's focusing on the meaning of the scene rather than on the irrelevant details. Imagine how much energy and brain mass it would take for us to remember every single person, place, or thing we encountered. The things that matter, a conversation with a coworker, your child's first step, would be drowned by a deluge of information. So when there are minor changes to the world around us, we often don't pick up on them. There are two similar phenomena at work.
Inattentional blindness is the failure to notice something that's fully obvious right there in front of you when your attention is engaged on something or someone else. Change blindness is a failure to notice a difference between what's there right now and what was there a moment ago.
Scientists such as Daniel Simons from the University of Illinois have spent years devising experiments testing just how perceptive and unperceptive humans actually are.
So we feel like we're aware of everything, that we're taking in all of the details, and that if something unimportant happens, we'll automatically notice it. It'll capture our attention. The reality is that we often don't notice unexpected things because we're aware of far less of our world than we think we are.
So how much or how little are we actually aware of? We decided to recreate one of Simon's most famous experiments to see for ourselves. Here's the setup. Our senior series producer, Vin, poses as a lost pedestrian and asks a passerby for directions.
Excuse me? I'm looking for the skyline.
Then, we break the two up, walking through them holding a large sheet of wood. Now watch as I replace Vin. You might think people would notice the switch, but almost half the time, they didn't. Of course, that means more than half the time they did.
Ooh.
We only tried the experiment 9 times, and by no means was it good science. But we were surprised 4 people didn't notice the switch. In Simon's original experiment, 7 out of 15 people didn't either. So what determines whether or not you can figure out the switch?
When you look at another person, you encode what's relevant for what you're doing right then, in that case, giving directions, and you don't pay attention to the details that are irrelevant, say what color their shirt is or exactly how tall they are. As long as you are able to make sense of the meaning of the scene and roughly the main categories of that person, say their height, their age, what race they are, what sex they are, as long as those important things don't change, the meaning of the scene really hasn't changed and you're not going to notice that anything's different.
Scientists have documented...
Okay, we don't need to watch the rest of this, but it is good from Nova. It is a little bit longer, but the idea of change blindness and that door scene, the piece of wood, is actually a very famous experiment. Another one that I've seen that you may have heard of is that there was also an experiment that was done where they actually invited people in to participate in an experiment, and they walk into this kind of lobby area, and there's this big sign over this kind of desk, right, where it says "Experiment here." And so they walk up to this desk, and it's kind of one of those platforms where it's a counter, and then it's got, you know, the like cabinets underneath and everything. And the people walk up and they said, "Yeah, I'm here for the psychology, you know, for the experiment." And They said, oh, yes, okay, hold on, I need to get you this form. And so then the person will go, that they were talking to, ducks down underneath the counter, and then somebody else pops up with the form and says, oh, here you go, just need to fill this out and go down the hall to the left and, you know, second door on the left and talk to somebody there. And more often than not, people did not notice that it was a different person that gave them the form than the person that actually, you know, they approached. Again, another example of change blindness, because they actually changed something in environment, but nobody actually noticed. So those are two examples of what selective attention can do. All right, the last thing I want to talk about in this video is thresholds. So thresholds, you can talk about absolute threshold, and the idea of absolute threshold is the idea that there is a minimum amount of stimulation that is needed to detect something 50% of the time. So how strong does a smell have to be for you to smell it half the time? Or how much light does, for example, this candle here have to give off in a completely dark environment, okay, for you to actually notice? That's what we call absolute threshold. In class, I did an experiment. I usually use Pine Solve, and I have a container of Pine Solve, and I have somebody stand at the very opposite end of the room, and I tell them, okay, I want you to smell and tell me, take a step forward every time you cannot smell the Pine Sol. And when you can smell the Pine Sol, stop. And that would tell us, and I said, okay, now once you actually get to the point where you can smell the Pine Sol, take a step back. And now you're going to be able to kind of smell it, maybe, maybe not. That's your absolute threshold, okay? Now, within this, then you can also talk about subliminal stimulation. So anything that's below your absolute threshold is this subliminal message idea, right? So the question is, does subliminal messages actually affect us? So subliminal messages, you know, are going to be these hidden things in there, and advertisers use it a lot, as well as, for example, actual business owners. I actually read about a business, I think it was in the UK, where it was like a coffee shop or something like that, where they were tired of all the teenagers coming around and hanging out, and they didn't buy anything or whatever, and so they wanted to get rid of the teenagers. So what they did was they actually projected this high frequency pitch that only teenagers could hear, but was a subliminal message for everybody else, and it basically kept all the teenagers away and didn't bother any of the older customers. Okay, so does it affect us? Yeah. This one, for example, is Wendy's logo. Have you ever noticed Wendy's, the little girl, her little collar here? It spells out mom. You see that? Yeah. That was done on purpose. This one is a little harder to see. This one is a advertisement for the 99-cent KFC snacker, and I know that the lettuce looks kind of neon green, and it's kind of hard to pick out. But right here is a dollar bill. Can you see that? Subliminal message. Not necessarily the greatest one, but a lot of logos, messages, and logos have a lot of things, you know, that were subliminal. And the last thing that I want to talk about was Weber's Law. And this is an idea from a guy by the name of Ernest Weber, who basically said that for a difference to be perceptible, stimuli must be different by a constant proportion. So in order for you to notice the difference, it has to be proportional to what was originally there. Another experiment I do in class is I have quarters. And so I have two envelopes, and I have one quarter in one envelope, and I have two quarters in another envelope. And so I usually have a student that comes up, closes their eyes, and I place one envelope in each hand, and I say, okay, which envelope contains the two quarters, without opening your eyes? And most people can easily guess that. However, then I also ask them to take off their shoes, and then I have them hold their shoes, and I put the envelopes in their shoes, and then they have to guess which shoe contains the envelope with two quarters. That one is a lot harder because the difference between the weights is not going to be a constant proportion, because here's what happens is the difference in the weight of the shoes, okay, it's not going to be a whole lot of difference in the weight of the shoes, but the difference in the weight of the envelopes, yes, okay, there's a constant proportion there. That's what we mean by Weber's Law. Okay, that's it for now. Let me know if you have any questions.